Welcome to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your preferred platform. It really helps us reach more developers like you.
That's right, Sheila. Your support means the world to us. Now let's get started with today's exciting topic.
Absolutely. We're kicking off Season 2, Core Holepunch Technologies, and our first chapter is all about introducing Holepunch. Today, we'll be giving you an overview of the Holepunch ecosystem. But before we begin, I have a tricky quiz question for our listeners. Ready?
I'm always ready for a good brain teaser, Sheila. Let's hear it.
All right, here goes. In the context of decentralized systems, what does the acronym DHT stand for? And why is it important?
Ooh, that's a great question, Sheila. It touches on a fundamental concept in decentralized systems. I'm sure our listeners who've been following along will have some ideas. It's not just about knowing the acronym, but understanding its significance in the decentralized world. This should get them thinking.
Exactly, Victor. We'll reveal the answer at the end of the episode, so stay tuned, listeners. Now let's start by defining some key terms. Victor, could you explain what Holepunch is?
Certainly. Holepunch is an ecosystem of open-source technologies designed to build peer-to-peer applications. Think of it as a toolbox filled with powerful instruments that developers can use to create decentralized software. The name Holepunch comes from the idea of punching holes through firewalls and NATs to establish direct connections between peers.
That's a great analogy, Victor. So, if Holepunch is a toolbox, what are some of the main tools inside it?
Great question. The core technologies in the Holepunch ecosystem include Hypercore, Hyperswarm, and Hyperbee. Hypercore is a secure, distributed append-only log. Hyperswarm is a distributed networking stack for connecting peers, and Hyperbee is a distributed key-value store built on top of Hypercore.
Wow, that's quite a collection. It sounds like these technologies work together to create a complete environment for building decentralized apps. Can you give us an example of how they might be used in a real-world application?
Absolutely. Let's take a decentralized chat application as an example. You could use Hyperswarm to discover and connect with other users, Hypercore to store and sync message history, and Hyperbee to manage user profiles or channel information. Together, these tools allow you to create a fully functional chat app without relying on centralized servers.
That's fascinating. It really highlights how versatile the Holepunch ecosystem is. Now, I'm curious about the basic principles behind Holepunch. What makes it different from other development frameworks?
The key principle of Holepunch is true peer-to-peer interaction. Unlike many systems that claim to be decentralized but still rely on some central components, Holepunch is designed for direct communication between peers. It also emphasizes modularity, allowing developers to use only the components they need.
I see. So it's not just about being decentralized, but about being truly peer-to-peer. That must come with some unique challenges. What are some of the difficulties developers might face when working with Holepunch?
Great point, Sheila. One of the main challenges is the paradigm shift in thinking. Developers used to client-server architectures need to adjust to a world where every peer is both a client and a server. There are also challenges related to data consistency, offline operations, and NAT traversal. However, Holepunch provides tools to address these issues.
That makes sense. It sounds like there's a learning curve, but the payoff is the ability to create truly decentralized applications. Are there any common misunderstandings about Holepunch that we should address?
Absolutely. One common misconception is that Holepunch is only for cryptocurrency or blockchain applications. While it can be used for those, it's much more versatile. Another is that peer-to-peer systems can't scale. In reality, well-designed P2P systems can be highly scalable, often more so than centralized ones.
Those are important points to clarify. Now, let's talk about best practices. What advice would you give to developers starting with Holepunch?
My top tip would be to start small. Begin by understanding each component individually before trying to build complex applications. Also, always consider the user experience. Decentralized doesn't have to mean difficult to use. Finally, join the Holepunch community. The ecosystem is evolving rapidly, and the community is a great resource for learning and problem-solving.
Excellent advice, Victor. Before we wrap up, do you have any interesting facts about Holepunch to share with our listeners?
Indeed. Here's a fun fact. The Holepunch ecosystem was originally developed as part of the DAT project, which aimed to create a distributed data sharing protocol. It has since evolved into its own ecosystem, but it carries forward that spirit of open distributed data sharing.
That's really interesting. It's always fascinating to learn about the history behind these technologies. Now, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The acronym DHT stands for Distributed Hash Table. It's important in decentralized systems because it provides a way to store and retrieve data in a distributed network without any central coordination. In the context of Holepunch, DHTs are used in Hyperswarm for peer discovery and routing.
Excellent explanation, Victor. To summarize today's episode, we've introduced the Holepunch ecosystem, a powerful toolbox for building peer-to-peer applications. We covered its core technologies, Hypercore, Hyperswarm, and Hyperbee, and discussed how they work together to enable truly decentralized apps. We also touched on the challenges and best practices for developers working with Holepunch.
That's right, Sheila. We've only scratched the surface of what Holepunch can do, but I hope our listeners are excited to learn more. In the coming episodes, we'll dive deeper into each of these technologies and explore how to use them effectively.
Absolutely, Victor. And to our listeners, we'd love to hear from you. Visit crashcasts.com to learn more about decentralized application development. If you enjoyed this episode, please subscribe to the podcast and join our Discord community. Your support on Patreon also goes a long way in helping us create more content like this. Until next time, happy coding.